I was muted then. Sorry. Hello. Welcome to this class. I'm Laura Lewis, and we're going to talk about plant responses to their environment. So it's going to be 6-mark questions that we're going to look at today, and answering those to get full marks. So let's go to the document. Let's have a look at some questions. Okay. So the first question, the important thing to do is to read the question here. Okay, that's the most important thing. So in this question, you'll be assessed on using good English, organising information clearly, and using specialist terms where appropriate. So we just use keywords, but write it in a way that makes sense. Okay, so you can write bullet points, but you won't get full marks if it's not a proper sentence. They'll pick up certain words, but you won't get full marks. So plants respond to different environmental factors. Okay, describe how different environmental factors affect: number 1, the direction of growth of roots and the direction of growth of shoots. Okay, so roots obviously in the ground, shoots above the ground. In your answer, you should refer to the role of plant hormones. Okay, do not refer to the artificial use of plant hormones by gardeners or scientists. So it's just the natural plant hormones that the plants have. Okay, so let's have a look. So we've got environmental. So what environmental factors can there be? So let's think about those environmental factors. So it could be obviously the amount of light. Okay, light, and that includes the amount of and the direction of it, doesn't it? Amount and direction of light. Okay, so if you put a plant by a window, you've got light coming in one side but not the other. Okay, and it might all grow towards light. If you've ever seen that. So direction of gravity, so let's put that underneath. Direction of gravity, well, it's usually, as we say, downwards, but if you put a plant on the wall or something, I mean, it would affect it, wouldn't it? Like, on a hanging basket or something, that it would affect its growth. Okay. Moisture, so amount of moisture or water. So some plants actually get it from the air. Obviously, most get it from the ground or the soil. But some can actually take it in. Some rainforest plants can take it in through their stems. A bit more unusual. Okay, so there are things that can actually the environmental factors. So I'm going to make a little bit of a thing underneath it. Okay, so effects on direction of growth. Okay, so start off with shoots grow upwards. Obviously, we know that. So shoots grow upwards and towards the light. Okay, so if you've ever planted a seed and seen it grow, we know that it grows upwards and towards the light, because that's how it knows where to go, doesn't it? It goes towards the light. Okay. They grow against the force. They're going upwards. They're coming out of the ground. They grow against. Okay. They grow against the force of gravity. Okay. So that's the hormone that causes all this. Auxin is the hormone that controls plant growth. Okay. Right, so I'm going to just put in the next page for a minute because it's a bit clearer. Plant growth. Okay. What it will do. So it causes the auxin causes faster growth in shoots. Causes faster growth in shoots. Okay. In shoots. But the opposite, but slower growth in roots. Interesting. Okay, so shoots go upwards against the force of gravity, go towards the light. So, and roots, opposite, grow. So when something grows towards the light, it's called phototropism. Okay, phototropism. Okay. So roots grow downwards. Okay. Gravitropism. They go with gravity. They grow with gravity. Okay. They grow towards moisture. Good thing they do is because plants in a desert would otherwise they wouldn't survive. Towards moisture and water. Okay. Okay, so actually this is actually quite a simple question. Okay, we've answered it. Okay, so environmental factors, light, amount and direction of light, direction of gravity, amount of water and moisture. So auxin is the hormone that controls plant growth. Auxin causes faster growth in shoots, but slower growth. Ooh, see, that's always good to read your answer, isn't it? Yeah, you can make mistakes. So auxin is a hormone that controls plant growth. Auxin causes faster growth in shoots, but slower growth in roots. So shoots grow upwards and towards the light. So phototropism. They grow against the force of gravity because they're growing up. Roots grow downwards, gravitropism, and they grow with gravity. They grow towards moisture. Okay, so that's answered our question. So let's have a look at a different question. Okay. So this is an experiment, so it's a little bit different. Okay, so it says in this question, you will be assessed on using good English. That's another 6-mark one. Using good English, organising information clearly, and using specialist terms where appropriate. Okay, so this is sort of thing. It might be a bit new to you, but you can get asked about experiments. Okay, in exams. It's been a few years where students could be asked about experiments. Okay, so light intensity. So sorry, I'll read this quickly. So you're using good English, organising information clearly, as all 6-mark answers say, and using specialist terms where appropriate. So light intensity, carbon dioxide concentration, and temperature are all factors that affect the rate of photosynthesis. How would you investigate the effect of light intensity? So this is one of the factors, isn't it? It's light intensity on the rate of photosynthesis. Figure 3 shows some of the apparatus you might use. You've got a lamp, got some pondweed. That's a plant that grows in ponds. If you've got a pond, you'll know about it because it grows everywhere. A ruler and a beaker. Says you should include details of how you set up the apparatus, materials you would use, the measurements you would make, and how you'd make it a fair test. So actually what we do, investigating the effect of light intensity on the rate. Let's write that down, what we're actually doing. So we're looking at investigating the effect of light intensity. Okay, light intensity on plant growth. Okay, that's actually what we're doing. So let's write that down. So light intensity, so it means how strong the light is. Okay, so we've got pondweed. So if it's from a pond, it needs to go in the water. Okay, so the first thing we need to do is place the pondweed in a beaker of water. Okay, so when photosynthesis occurs, what is actually produced? So it's oxygen is produced, isn't it? So when a plant photosynthesizes, can we see oxygen? No, we can't. So the reason why we use a water plant is that when it produces oxygen, which is gas, bubbles are formed, so we can see it. When a plant photosynthesizes, it produces oxygen. Okay. When the plant is in water, we will see bubbles. Okay. So what can we do? So we know that now. So we're talking about so we need to shine the light. So the light we need photosynthesis, need light, so we need the lamp on. The light will be shone on the pondweed in the beaker. Okay. So as well, you could draw this. Okay, if you find it hard to describe, draw a diagram to show it. That always really helps. Okay, is that so? If someone you can't describe, drawing a diagram, honestly, that you will get marks for drawing a diagram and labeling it. Okay. So pondweed on the week. So now we need a method to control how intense it is. Okay, so the way of doing that, the easiest way, would be just to change the distance of the lamp from the beaker of pondweed. So to change the intensity of, I keep putting extra letters everywhere, don't I? Intensity of light on the pondweed. Okay, we will vary the distance. Okay. So what we need to do is how we will measure. Right, we need to set something called a rate. Okay, when we see the word rate, it means something over time. Okay, how we measure the rate of photosynthesis. So we can do this in a bullet point or number form. So place lamp at, so example, we could do it in 5 centimeters from the beaker with pondweed. Okay. Set a timer for 5 minutes and measure, or should I say count, because that's what you'll be doing. Count the number of bubbles produced. A second, place lamp at 10 centimeters from the beaker, and you need to have the same time as well. Set a timer for 5 minutes and count the bubbles. We repeat the above until something sensible like 50 centimeters. Okay, so let's have a look what a rate is. So a rate is the amount of bubbles produced over time. Okay, so it will be, so example, for example, 20 bubbles per 5 minutes is a rate. Thing we haven't talked about is control variables. What we need to keep the same. So let's talk a little bit about variables here. So we've got independent variable. Independent variable. Independent variable. That's coming up like that. Independent. It's just my typing. I don't know how to spell things. That's typing. Okay, independent variable. So that is what we control. We change. Okay. So the distance, that's the independent variable. The dependent variable is what happens after we do that. Okay, dependent variable. I typed too fast. Very good. Okay, so what we measure. So the amount of bubbles produced over 5 minutes. Okay. And that really is the rate of photosynthesis. Control variables, so we need to keep the same for each one, okay? Because there's other things that could affect this, isn't there? So we need to do it away from windows, obviously with light. that could affect light levels. Okay, away from drafts. Okay, so like through open doors and things, that could affect carbon dioxide levels. And we have to ensure the temperature, because that could be a factor. The temperature remains the same. So obviously, use a ruler to measure the distance. Go quite a big ruler. That will include all of the above when you know how to measure a distance. So, investigating the effect of light intensity on plant growth. Okay. So we've got lamp, pondweed, ruler, beaker. So we've used all of those. So we place the pondweed in a beaker of water. When a plant photosynthesizes, it produces oxygen. When the plant is in water, we will see bubbles. The light will be shone on the pondweed in the beaker. The change in intensity of light on the pondweed will vary the distance. So how we will measure the rate of photosynthesis, rate of the photosynthesis. See, always read your answer, always read it. So number 1, place lamp at 5 centimeters from the beaker with pondweed. Set a timer for 5 minutes and count the number of bubbles produced. Use the ruler to measure the distance. Number 2, place lamp at 10 centimeters from the beaker. Set a timer for 5 minutes and count the bubbles. 3, repeat the above until 50 centimeters, a sensible amount. A rate is the amount of bubbles produced over time. For example, 20 bubbles per 5 minutes is a rate. Independent variable, what we control, change the distance. The dependent variable, what we measure, or the amount of bubbles produced over 5 minutes, is the rate of photosynthesis. Control variables, so this will need to keep the same, should have said that. Okay, so away from light windows that could affect light levels, away from drafts that could affect carbon dioxide levels, that would turn into an effect. Okay, that could affect. Okay, carbon dioxide levels, ensure the temperature remains the same. Okay, so if you want to read back on things, so that's an experiment. So thank you for joining the class. Hope to see you in a future one. Thank you and goodbye.